So far, we have seen the solution of this particular case, where there is actually only one variable. And the solution is the Catalan numbers, where the argument n depends on the number of customers. However, we want to generalize a bit, namely, loosening one particular constraint about the number of people depositing and borrowing money. Then, the solution depends on both the values of A and C, but I write that as C with subscripts A minus C and C instead. Notice that C0n is the same as Cn. We go back to the grid again, which is the tilted tree diagram we used to analyze the scenario. Any path leading to a particular point corresponds to a particular set of values of A and C, and in this case corresponding to 4 depositing money and 2 borrowing money, which means that the number of paths to this yellow point is C with subscripts 2 and 2. Here, the first 2 represents the difference between the number of people depositing and borrowing, while the second 2 is the number of people borrowing money. What you can think of using this notation is that the first number tells you which diagonal from the main one, and the second number tells you which entry on the diagonal. Can we express this in terms of other similar C something? Let's consider this green point. The last step going to the green dot must be from either this orange dot or the yellow dot. So that means the number of paths to the green dot, which is denoted as C13, is equal to C03, which is the number of paths to the orange dot, plus C22, the number of paths to the yellow dot. By rearranging, we can express C22 in terms of numbers on the previous diagonals. More generally, we have this recurrence relation. There are 2 base cases we need to consider before using the recurrence relation. The first one is C0k. This just corresponds to paths leading up to points on the red main diagonal, which is just the Catalan numbers themselves. Now consider the paths leading up to the red dot on the main diagonal. All paths have to pass through the green dot, so C1k are also Catalan numbers, just shifted by 1 place. With these 3 relations, we can already find all the values of C and k by repeatedly applying this powerful recurrence relation. We are now going to use this recurrence relation to try to guess the formula of C and k only in terms of n and k. To do that, we first write out the formula for C0k and C1k in terms of factorials only. Then by using the recurrence relation, we can obtain C2n. By simply substituting n equals 2 into the recurrence relation, we obtain this formula. Then by substituting the formula in, we can then do some algebra. Now we can do the same thing again to obtain C3k. You might have already spotted the pattern, but there is no harm in doing one more. Now C4k looks like this, which should confirm your belief in the pattern. So now the general form of C and k can be found using this general formula, and in fact, you can check that this formula also holds for n equals 0 and 1. Of course, we can't say this is a logical proof, so we can use mathematical induction to make these all valid if you want. Now we have generalized the Catalan numbers of only one variable n to another class of numbers with two variables by loosening the constraint that a must equal to c. It is also possible to generalize in another direction by considering the original amount of cash that the bank has is not necessarily zero, or even considering both generalizations at the same time. You can see how the grids change when you generalize these conditions. All these scenarios have known formula for the number of ways of queuing up the customers. However, notice that in all these generalized cases, we don't change the condition about the deposit and loan amount, and in fact, it would be very tedious if we consider B not equal to D. The next video is going to be a personal anecdote on how this video series came about, because this project actually meant something to me. It will be very different from what I usually do, but I hope you will enjoy the next video. If you enjoyed this video, don't forget to like and share this video and subscribe to the channel with notifications on. Stay tuned for the next video. See you next time.